Okay, good afternoon once again. Today we are going to look at LangChain. Last Wednesday we had already looked at the what I would consider the last two elements of use of AI or LLMs, boosting the capability or the capacity of LLMs. We have started off at the beginning by just understanding LLMs, understanding the limitations of LLMs. We had also gone ahead to even look at how we can access LLMs, the LLM capabilities. We looked at how we could run them, directly, or how we could um, access them on APIs. We looked at how LLMs, improve our own capability. We looked at different types of LLMs, you know, for vision, for speech, multimodal LLMs, for embedding, and for physical, basically language translation and so on. Then we looked at stacks and so on. And then we talked about the things you do with LLMs. So we talked about prompting, prompt engineering. We talked about prompt chains, talked about how to optimize the prompt chains and how we can use these AI agents to improve our workflow, right? Then we used some of the SDKs, and then we talked about how we could boost the capacity or capability of LLMs using um, what we call retrieval augmented generation. We looked at the vector databases, semantic search, embeddings, and so on. So these are all like ways of saying, okay, we have LLMs, right? They can reason, but they cannot do much more than that. They have knowledge, but they can't do much more than that. So we started talking about extending their capabilities. So we talked about the RAG, which was the first way we extended the capability. And then just this week, we talked about functions and tools. So at the end of the day, LLMs can only really become very useful when we're able to enhance their reasoning capability with other things. So now we've done all of that, but a lot of the code that we wrote was kind of, ad hoc. We wrote a lot of code from scratch, mainly because I needed everyone to have a very good understanding of what's going on under the hood so that later on it will be easy. So if I tell you what's a RAG, how does a RAG work, you understand how it works. If I tell you, you know, what's a tool, what's a function call, you understand that it is basically a prompt chain. And because you understand what a prompt chain is, you also understand requirements. You understand things like the token count, the token window constraints. So you know that if you're using tools, there's additional count to your token window size and all of that. But when we now come to building real world products in production, like we just discussed, right? With robustness, reliability, scalability, and all of that, we now ask ourselves, what are the best practices? What are the programming, you know, paradigms? What are the design patterns that we should be following? And for AI development, it is not that much different from anything else. You still have principles of separation of concerns, reusability, adaptability, swappability, and all of that. So writing code the way we have been writing will not really work. And that is where the frameworks, the agentic frameworks come in. The first one we're going to look at is LangChain. Basically, these are frameworks that help us write code, you know, properly. So yes, LLMs are stateless, they are text only, but we need to boost their capability. So that's just what I said. Tools, memory, which is context. So again, remember, for example, when we're doing the prompt chaining, we have to keep track of previous conversations and keep sending it back, loading it back into the context, right? And then there's reasoning over multiple steps and so on. So At the end of the day, it's not very practical or even advisable to keep writing these things this way from scratch and so on. So LangChain is a library, an open source library that came to the fore sometime in the year 2022, right? Shortly after ChatGPT became very popular. It was brought as basically, as the name implies, a tool that helps you to easily chain prompts and so on and other activities. But over time, it has grown and it has been adopted by a lot of people. So it's become like the go-to framework, orchestration framework. And what LangChain does is it simplifies building of applications that are powered by LLMs. It provides tools. We talked about tools. It provides components. LangChain exists both in Python and in JavaScript, right? And you can use them. They basically have the same interface, the same pattern. So if I have enough time, I'm going to do both Python examples and JavaScript examples. So LangChain allows you to connect these LLMs with external data sources. We talked about MCP as well. MCP is the Model Context Protocol, which allows you to connect your LLM to various data sources without having to rewrite the connection code or the connectivity code all the time, right? So once you are able to connect LLMs with data sources, it expands its knowledge. You connect it with tools and additional capabilities. It is now able to actually do stuff rather than just knowing stuff, right? And so you are able to create multi-step applications. And even the multi-step applications, which is a chaining, and what we call the react, which is reason and then act. And then the result of action, you reason around it again and then take more actions. That's what brings us to the agentic capabilities of large language models. So LangChain helps us to do all of this really easily by abstracting away a lot of the things that we would normally have written by ourselves manually. And we are going to look at all of that. So LangChain is built up around LLMs, abstraction of LLMs, right, or models, abstraction of prompts and prompting, abstraction of chains, what we call chains, which in the recent versions of LangChain, it has evolved. So we will look at that also. Abstraction of vector stores. So remember when we're doing the RAGs, we talked about different kinds of vector stores, document loaders, right, and agents. The truth of the matter is that what LangChain basically does is it introduces an abstraction layer around all of these things so that you can swap things out, right? You don't need to write your code to use a Gemini API or Gemini SDK specifically. In case in future you want to switch to, OpenAI or you want to switch to, any other provider, right? You don't have to rewrite your code. That's the main thing that LangChain does, and it provides this kind of swappability across all of these five and more that we have looked at. So LangChain basically works by chaining together different components. That's why it's called LangChain. By the way, Lang is a word in German that means long. It's a Germanic, word. Lang means long. So LangChain basically means a long chain. And it works by chaining together different components and actions to create cohesive and sophisticated AI workflows, right? So some of the modules which we'll talk about, we have the model IO, which is basically abstraction around the model. It's the interface that allows you to interact with different LLMs via via their APIs, the OpenAI, Google, Anthropic, and all the rest, or to even directly, access models that are installed locally on your system, that you are running inference locally as well. So because it provides a standard interface, it allows you to swap between different models without rewriting your core business logic or business code. It also has chains. So chains are basically sequences of things. So you can basically link things together, right? You can link models to prompts to memory and all of that. You can just chain stuff, right? So the concept of chaining allows you to break down the complex task into smaller manageable steps, and then you chain the steps. So then it really allows us to handle prompts generally. Because if you look at it, the way we've been writing prompts, the prompt is a string, right? But in the modern world of AI programming, the prompt becomes, think of it as a definition document. It defines something. It's a requirements document, right? In fact, it's a program. It's a computer program, but it is only a fuzzy kind of computer program, and it is written in natural language. It's not written using any of the high-level programming languages that we know, right? And that's how the evolution of programming has been. In the old days, we started programming with machine code, where people write zeros and ones, bits and bytes. And then from machine code, those were the days of punch cards, right? So when you punch those cards, you're actually punching zeros and ones in the cards, and you load those punch cards into computers. From there, we went to assembly language, which is a very low level language, right? That allows you to type three letter commands or four letter commands. And what happens is that you now have an assembler, which is a program that will convert those assembly language code into machine code, which are the ones and zeros, the bits and bytes. And then from assembly language, we went to the higher level languages, right? And the higher level language, you have two tiers of them. The ones that are really very low level, higher level language, like the C, C++, and so on, right? Which are kind of, they feel, they still look natural, but they see a lot of symbolism there. Then you have the other kinds of higher level language like Python that we are using now, that is more like natural language, but it's still high level language. It still has structure, it still has rules that you have to follow and all of that. So the next level of evolution of programming language now is prompts, which is now natural language. You are just basically typing instructions the way you would have done it if you are speaking to another human being. And that's where we are now. So one of the things that we have been doing in the past is that the prompt will just be littered all over in your code. What if I needed to change the prompt? Does it mean I need to change the code? See? So one of the things that, you know, some of you may have thought about it. Okay, maybe I should pull my prompts out and put them in a separate file so that my actual code, which is still the higher level code. So now we have high level code living side by side with prompt, which is natural language code, right? Or natural language instructions. But I don't want to mix them. So I take the prompts out and I put them in files and I can load them. But it becomes very cumbersome to manage those. And even in the prompts, you have placeholders that you have to inject and replace, like when we're doing prompt chaining and so on. So all of this is helped and, it's abstracted by LangChain using this whole prompt system, where it allows you to create prompt templates. A prompt template is basically a file, right, that contains your prompt. And then even the prompt itself has placeholders. Sometimes it may not even be in a file, it could just be a string, but it has placeholders. So it allows you to easily manage the placeholders and replace them without even thinking too hard about it. So LangChain provides that and takes that headache away from us. And then we also talk about data retrieval with RAGs. So LangChain provides tools that allow us to easily implement RAGs. And one of the tasks we are going to do is to do another RAG, but this time use LangChain. And you're going to see how much easier it is to build a RAG with LangChain, right? So we'll look at that shortly. Then we talk about memory, which if you are doing a sequence of conversations with LLMs, remember LLM is stateless. LLM does not remember the last conversation. The only reason why LLM remembers the last conversation is because you are stacking up the whole history into a list and you still send it to it. as part of the prompt. So it knows, oh, okay, this is what we discussed. If you do not give it that context, that history, it's going to always start from scratch. So what the truth of the matter is, if you're using ChatGPT, what most of us don't realize is that the front end of ChatGPT, that interface you're operating with, is actually keeping track of the conversation and sending it. If you were to directly call the API without any history, it will not remember the previous discussion. So memory, then agents, right? So what's an agent? An agent is basically a large language model that is capable of reasoning. You give it access to external data, and then you give it ability to take action with tools, right? And then you give it the ability, that's basically based on prompt, to break this task into smaller bits and take them step by step. So LangChain allows us to do all of this. And then there's a bunch of lots of other integrations, which we are going to look at. So the additional things which LangChain has that makes it really great and powerful is that it offers additional tools that helps you to work better with the core LangChain framework. So you have LangGraph. LangGraph is what we call an agent orchestration framework. It's basically a framework that allows you to pull together, you know, different agents that you may have created and to orchestrate them. Because an agent is basically a piece of LLM that, like I said, LLM plus knowledge plus um, tools that does a particular thing, specific thing, right? Or a small narrow scope of things. And then you could build different agents that do different things. How do you orchestrate those? So you use LangGraph. Then Langsmith is for debugging. It helps you to debug and test your code. It helps you to monitor performance and behavior of your LLM applications in production. Then LangServe is a library that allows you to deploy your LangChain chains as a production-ready API. So those are the additional tools. There are a bunch of others as well, but these are the few, to look at. So we are going to talk about the LangChain core building blocks, and we're going to um, go through each of them, right? So like I said, these are the building blocks we'll look at. The models, which is a unified interface that allows us to interact with different LLMs, and we're not too worried about, what kind of LLM it is and so on. Then prompts, like I said, allows you to um, manage prompts easily, right? And ensure that your prompts are structured, consistent interface. And there's also type hinting and type safe, work that allows you to ensure that you're not making mistakes. And like I said, LangChain exists both in Python and in TypeScript. So in TypeScript, of course, that's JavaScript. Then we have chains. So chains allows you to chain different things, sequence of calls to models, data sources, other utilities. So it helps you to link steps together and perform complex tasks. By the way, the chain interface has been improved. So we're going to still look at the old way, and then we're also going to look at the new way of handling chains. Tools, we talked about tools already. Functions, API calls, you know, which allows your LLM to do stuff and interact with the outside world. Memory is where you store context from previous interactions so that your conversation continues to make sense, and and then indexes, which allows you to store data, to be able to index those data and all of that. There are a bunch of other things that LangChain also does for you. And then the agents themselves, which is the sum total of all of these things that allow us to build agents. So those are able to reason and autonomously decide on a sequence of actions to take. And then they go ahead to take those actions or orchestrate other agents to take actions. So we will go into it directly, right? Um, let's go and take a look at what LangChain does for us. So I'm going to pull out a Jupyter notebook, which I had already prepped. And in addition to just bringing it up, um, I'm going to walk through the code so we can see. Right. So we are still going to follow those steps. So we are going to look at models. How does LangChain help us to handle models? How does LangChain help us to handle prompts, chains, tools, memory, indexes, and agents? So let's start with models. So normally, right, what we used to do before is if we want to do stuff without LangChain, we would do something like this, right? By the way, this reminds me, I have to go get the necessary API key. So I'm going to do that now. Let me first of all create, I need to connect to a runtime. Connected. So let me just create a .env. Then I'm going to pull in this. So usually before, what we have learned up till now is if you want to access an LLM, you just use either an SDK or you can do a direct API call. A direct API call is even a level below this using an SDK, right? Using an SDK is easy, right? And you can put in things like tools and so on, tool calls like we did earlier. But the main challenge with, just doing it this way is that if I want to swap to another one, right? If I want to swap to another one, I end up with some kind of difficulty. So here, I always like to use Open Router here, mainly because um, OpenAI doesn't give me as many models as I would like. So we'll use Open Router, but AI API v1, right? And then the key, we will load it from .env. So this is OS, right? So this will be Open Router. Okay, so this is typically what we were doing before, right? If I want to access this LLM, and run it. So here is a simple thing. Let me import this first. So here's a simple thing. I have a simple um, prompt. So first of all, you can see we have a system prompt here, right? And then you have the user prompt. So I need to change this model. So I'm going to use a Nemotron. I can get that straight from Open Router. Um, NVIDIA keeps giving us nice models. So the latest one they have that is free is the Nemotron 3 Nano. This is a small language mixture of experts model with high compute efficiency, right? You can use it. It's a small model, but I'm still going to stick to the 12B2VL, which is what I've been using, at least until I run out of my free stuff. I still have the 9B V2, which is also still free. So let's go with this. This is a bigger model. This is a 12 billion parameter model versus this one, which is a 9 billion parameter model. Um, so it's always a good idea to go with bigger models if you can. Bigger models are smarter, so you don't have to do a lot of work um, with bigger models. So if I wanted to do this and I wanted to explain, so look at this now. The code here is, of course, I specify the model. This is just setting things up. Then I give it a system message. And the method we are using to give a system message is to say role is system, right? And then the content is UI technical tutor. So this is a system message. Then the actual message is explain this topic briefly. So we wanted to explain a topic. So this is where I run it and I ask it to explain vector databases. Now, one of the things I like to do here is because a lot of these LLMs like to generate Markdown. So I will also import Markdown. Let me do this in a separate, well, let me do this in a separate, let me keep this, but let me import Markdown um, so that I can display the Markdown properly, right? So IPython.display, I'll import Markdown. So I just import Markdown. Okay. So instead of just printing, I will just display the Markdown. I'll display the Markdown. Okay. So this is what we have been doing all this while, right? And if I run this and then I run this, so it calls the API, right? And hopefully we'll get that coming back. But the problem with this approach now is if later on I want to switch to a different provider like Anthropic, okay, then I will have to write the code because the way maybe the shape of the return value may be different. This one is response or content 0.text, while this one is response or choices 0.message or content. So it's not very easy to kind of, you know, come up with a way that I can easily change it and say, okay, I don't want this one. I want this one, right? So this is one of the problems with doing it this way. If I wanted to swap out to Anthropic, I'll have to rewrite the code. This is the problem. So how does LangChain solve this problem? I think, I don't know what's going on. Let me, I think that model is not available. So let me see if I can get another one. Let's take this little model. So, but the thing is, if I wanted to do with Anthropic, and I'm not going to bother, like writing the code. Um, okay. So I get a response and that's nice. So I get this response, and because I use Markdown, so it looks pretty neat, vector database, it gives me all of this. But the problem, like we're saying, is if I needed to use a different model from a different vendor, I would have to almost rewrite the code for it, right? If I want to even do Gemini now, right? This is switching to Anthropic. I don't have an API key for Anthropic, and it's going to take a bit of time. So let me not use Anthropic. Let me not try this, but let me just say, okay, if I wanted to switch to Gemini, right, I would have to do a bunch of additional work, right? So just think about what I need to do, and I'm going to show it here. What do I need to do for me to do it, Gemini? I would have to Gemini from, not Gemini, from Google, import Gen AI, then yeah, I have to remember all of this, right? That's the interesting thing. There's so many different there's so many different ways, so you have to remember all of them, right? And then I have to do a new client equals yeah, um I don't think I need this API URL. And then I have to now do the explain. topic, and then response equals. I now have to remember how Gemini's own approach of generating text, which will not be the same as it. So I'm lucky because I I have Gemini itself kind of giving me these suggestions to complete, right? But even at that, I'm not sure what this is, so I still need to double check and make sure. But I have to remember all of this, right? Or I have to check where to go and reference it and all of that. There's a lot of information, so it's not even reasonable to expect that anybody will cram or memorize all of this. That's not the approach for you to use. You will not succeed. The approach for you to use is to understand the principle and how things work and understand the the under the hood, what's happening under the hood. But the specifics of things like, okay, which method should I call? You can't remember all the methods. So basically you have to go check documentation and so on. Or these days use an LLM to help you generate the code, or maybe look at previous code you have already written and all that kind of stuff. So those are some of the things. If not, I cannot say, oh, I remember exactly how, Gemini does this. So this is part of the challenge, right? This is part of the challenge with, so many different libraries, so many different SDKs and so on. So I'm going to go look for how Gemini does this, and I'm going to just use it to double check what I have here, what is that generated for me, because I don't even trust what is generated for me, right? So of course I've already seen that there's an error here. It should be client.models. The main reason why some of these LLMs will give you errors is because they are based on training data that's probably stale, right? So the training data might actually be 2022. And the interface, the API has changed. The way this thing is called has changed in the last 2 years. And it's still giving you the old way of calling it. And if I did this, I would probably have an error. I can even prove that, right? So let's do the same thing. I'm going to copy this here, right? So I'm going to copy this and I'm going to paste it here. So same thing, right? Display markdown, explain vector databases. I'm going to use the old one. Apart from the fact that I'm not even sure of this model, I'm not going to use this. I typically use, for Gemini, I typically use 2.5 Flash. But I think some in the last class, you could, if you remember, I basically got timed out on 2.5 Flash. So let me see if it's still available for me. So I run this. I expect that there will be a failure in generate text. If it works, that's cool, right? But I expect that there will be a failure simply because, um, oh yeah, so this is even where I have the failure, right? So um, we don't do configure anymore. In the new Gen AI, we just specify the API key here. So something I also forgot. So we'll get the API key. This should be Gemini. Um, and I also need to remember to add the API key here. Okay. Um, so let me do that quickly. Okay. Oh yeah. Yeah. I need to rerun the .env because I just added this, so I need to rerun the .env so that I get the recent keys. All right. So you can see this is actually the error I was waiting for to happen. The client doesn't have an attribute called generate text because it generated this thing for me, but it's not the the latest or most recent way of doing it. So that doesn't work, right? So now I change it and It's even telling me that doesn't even work. Oh, okay. Client.models. Sorry, this is a typo. It should be client.models. Generic content. Right. Uh, right. So yeah. So the API has changed and we're still using the old API, still asking me to use the old API. Content should normally be a list, but it can also be a single string, right? So maybe let me just keep the single string instead of the list. Okay, so it's now contents. This is one of the reasons why you should not just swallow what these things generate for you, right? They will fail. Okay, so this should work now because this is exactly what I have used in the past, right? So even this is wrong. The results um, should be text, response or text. So in the process of doing this, I want you to count how many times I ran it, and therefore how many token usages I have wasted. How many token usages I have wasted. Okay, so you see how difficult it was for me, you know, just to be able to achieve this same thing by switching to Gemini. I had already done it, yes. So let's assume I use Open Router and I got this very nice. And then I decided, okay, I want to switch to Gemini. And I had to write a bunch of code, do multiple cycles of testing before I finally get this outcome. Is this how you want, you cannot write at scale this way. So I'm not even going to talk about switching to Anthropic, right? So, because I have to go get, for this to work, I have to go get their API key and all of that. So I'm going to skip that. So those are the problems that you have, you know, um, different APIs, which we just saw, different message formats, different response, even. Then you have vendor lock-in. Vendor lock-in is a situation where you have only been using one LLM and you keep using that one. And maybe your entire code base, you have had coded all the LLM calls into that one vendor. Then the day you want to switch to another vendor is you now think about your technical debt, the amount of code you have to rewrite, and it's crazy. That's vendor lock-in. It makes switching so difficult, right? And then the last part of it is difficult for you to be able to experiment with multiple, different models to see, okay, which model will do better and so on. Because each time you have to switch to a different model, you have to write a whole new set of code. This is a problem. But what LangChain now does is that it now has a unified model. So we are going to look at what LangChain does. It has a unified invocation, a unified message format, and a unified output handling. So you don't need to worry about all of that. And once you use the right chat class, you are going to access it. So for us to use LangChain, by the way, you have to first of all install LangChain and then LangChain core. So we install that. If it is Python, use pip install. If it is JavaScript, you use pnpm install or npm install, whichever one you prefer to use. Then, in addition to installing LangChain core, which is needed by all LangChain stuff, you also need to install the particular um, library. So if I want to use OpenAI chats message LLM, I basically will install LangChain OpenAI, right? If I want to install if I want to use Grok, I'll install LangChain Grok. Now, what I'm going to do with this is for OpenAI, um, I will need to, again, because I have some challenge with this, I think I'll need to customize the to use the same open router that I was using. Because if I do just this will work, right? This will work straight up, but I'm going to get an error that I do not have access and all of that. So what I'm going to do is I'm going to modify this Okay, it's already telling me that. Okay, I need to set the OpenAI API key. I can do that, right? I can do that, and I will do that. But after I do that, the next error I will get will be it's telling me that I do not have the necessary credits and all of that. Okay, um, so let me get my OpenAI key. Give me a second. One second. OpenAI. So I'm going to put my OpenAI key here. So now OpenAI key is up. I need to rerun the load.env just to make sure I pull in that one, and then we'll run this. So I want you to look at the interface, how it looks like. Yeah, so I was expecting this to happen, and it has happened. So I'm going to switch to Open Router. So what to modify this? So first of all, right, you have you have a chat Open AI, right? So this chat Open AI which we import from LangChain Open AI is basically a class that encapsulates what we call an adapter pattern, right? Or a facade pattern, whichever one. It encapsulates the Open AI SDK and makes it to conform to the same interface that LangChain has defined for all LLM. So once you do this, you can then use the same way of calling the method. So for every single one, you call it the same way, irrespective of the internal details that is going on in those SDKs. So with the chat OpenAI, right? If I was using just OpenAI, where the API URL is the default value for OpenAI, and then the key. So the interesting thing is the key is tied to um what you have here, right? OpenAI API key. So that's the key, right? And I could then use this, but I would change the OpenAI API key to match my OpenRouter API key, and then uh, um, I can customize the um, URL. So like what I did before, I customized the base URL, but I also use this to get this. So I will use the same thing. But the main thing is that creating it uses the same interface, and then there's even a temperature thing there. So first of all, I will use my Nemotron, right? So that's what I'll use as the model. Okay. I'll use my Nemotron as a model. And then to further customize things, right? I will specify the key open AI. So you'll see that I get the open router API key. That's how I customize that by passing in this open AI API key. Then base would be the same. So the base is what I have. So this is the parameter you would use for the base, OpenAI API base. This is simply because chat OpenAI is, using the OpenAI thing. Then we can add the temperature and other things, right? Let me bring this additional stuff were just duplicates. So we have this. I'm not really sure about this temperature, but we will see how that works. So again, because I expect this to be marked down, I'm going to display markdown. All right. The interesting thing is this. So that works, right? You will see that the response, I don't need to try to remember the shape or form of the response because LangChain has standardized it. So I can just get it from response or content, right? I don't need to start thinking about tools. And then I can also, you can see I've been able to do this and I get the same thing, right? Now, let's do the same thing that we were trying to do. If I want to now switch, I'm not going to switch to Anthropic because again, like I said, I didn't have an Anthropic thing. But I'm going to switch to Grok, right? So let's say I want to switch to Grok. Of course, first I have to install the Grok extension that allows LangChain to interface with Grok. So I install LangChain Grok. While that is going on, I'm going to pull up my Grok API key. Okay. So let me put my Grok API key here. Right. And you see, I now run LangChain Grok, import Grok. Of course, the model will change because Grok might actually have this Nemotron on their server, right? Grok is just like OpenRouter. They are basically a provider of computational, compute for LLMs. They don't actually provide LLMs, but they host other third-party LLMs on their servers. So you will get an API key, right? And you can use. Take note of the fact that this is exactly the same. If not for the specific customizations I needed to do for Open AI, for the Open Router, right? This is because I wanted to redirect it to point to Open Router rather than Open AI. And this tells you that the chat OpenAI, you can use it for any other provider that conforms to OpenAI standards, right? You just need to tweak these two parameters. But everything else, the model, yes, I still have model, and then the temperature. And on Grok, I have Llama 3.18. I checked that already, so I'm not going to check again. But you can see that the amount of change I needed to do, the response is still the same. It's still response of content, right? So let's do that. So with this code, we now see how much easier it is to swap out. Okay, so Grok needs a setting called Grok API key, which I have put in here, but I did forget to refresh and reload the .env file. So I'm going to run this again to reload the .env file. And so I'll go and run Grok. And you see, much easier. How much code did I have to rewrite? Not a lot. Basically, I could have just copied the same thing and just changed chat OpenAI to chat Grok, and it would work. Okay, the models may be different, so I go find the models. Just two things I need to change. So this is the power of LLM that LangChain brings to the table, right? It basically allows you to be able to swap out as many models as possible. You have consistency in the API. You have model swapping. With LangChain, you just have a one-line change. But if you are doing it without, you have to write the whole code, right? API is consistent. Message formatting is standardized with LangChain. But without, you have to go look at so many different documentation to know how to access what is in the message. Output handling, custom passing, but here you just do dot content, response dot content. Then you have multi-model support. This one is hard, but this is built in. So For you as somebody who's now moving from I'm learning how to access LLMs, APIs to I want to build a production grade application. Why is this very important to you? Your design needs to be agnostic of provider because anything can happen anytime. Tomorrow, one provider can go down. In fact, your design should not be tied to a provider. Your design and your implementation should be able to switch. You should actually be able to actively switch in case a provider goes down or something happens. You switch to the next one, you switch to the next one, right? And then you can optimize your cost again because you're switching models. Like I said something like that last time. I said for different situations, you may want to use one model for one thing and a different model for a different thing. You may want to use one model for embedding, another model for language translation, another model for just reasoning, another model for image generation, another model for speech synthesis and speech recognition, right? So you can get a cost optimization by knowing which model to use. And LangChain allows you to easily switch without rewriting your code and having headaches. Failover strategy is what I just said, where if one provider fails for some reason, their server goes down or something, it's easy for you to just fail over, switch over to another provider, and so your own application is not affected. Then you can have hybrid deployments where you can use cloud-based models and you can also have your own local models, right? Combined, and you can switch between them. And you have, best of all, cleaner dependency boundaries. Well, that's the reason why it is a good idea and best practice to have a clean dependency boundary is for all of these reasons that we just mentioned. So LangChain allows you to basically hide all the details of accessing and communicating with LLMs behind a single interface, which you can now memorize that one and say, okay, you can try to remember because there are not a million that you have to remember, right? It's easier for you to master that single one and get good at it. So without LangChain, you would have to do all of this. You have to know the vendor SDK. The vendor SDK is still needed, right? But it is in the background, right? LangChain wraps it and it has a consistent interface. So, like I said, it's not just abstracting for abstraction's sake. It's to allow you to scale. It's to allow you to have failover maintainability, right? Reliability and experimentation if you want to try different models and so on. And then the vendor independence. So that is LangChain and models. And this is just a simple way. This is how you access models with LangChain. There's actually another way, right, which we can go check in their documentation. Maybe I can show you that two ways you can actually, let me just show us that quickly. Um, it's always good to check, um, to check documentation for all of these things. It helps, right? So I'm going to show you this quickly. There are two ways, right? One way is to use um, the model class, like what we have done. But the second way is for you. So there are two ways. The first is the model class, which is what we just do, right? You get the chat OpenAI, you get ensure that you have your environment variables in place, and then you just do chat OpenAI, you specify the model. Even the temperature, well, you could leave that out, right? But the second way is to use this init chat model, right? Again, in this case, it's OpenAI, but init chat model, the interesting thing with init chat model is that you did not specify which vendor. So LangChain kind of figures out how to access this model, this GPT-4 one, right? So it's something worth trying, and we will try it, later on. But here, because we've installed LangChain OpenAI, it's likely going to look for it in the OpenAI model class. But maybe if I install LangChain something else, or if I install multiple, it could search through all of them. Okay, so that's how LangChain helps with LLMs and accessing them. Now, let's talk about prompts. So, prompts are the backbone of any communication you will have with LLMs, right? We did prompt engineering, we did prompt chaining, and we did all of that. So, where prompts come in is, let's say you want to do prompt chaining or even just basic prompt that you are setting up and you want to inject some additional information, right? LangChain helps with that because LangChain, one of the things you want is reusability. I want to reuse that prompt, right? I want to be able to predict the output and I want to have a clear separation between logic and prompt text. In other words, the prompt text should not be embedded. See this kind of thing. For me personally, it's difficult for me to see what's going on, right? Because all of these strings embedded in the code, in the logic, can throw you off, right? So yeah, like I mentioned earlier, sometimes you could say, okay, let me take this out into a file and then load the file that contains the prompt. But then you also have these parameters here, this injected, you know, additional content, right? So normally without a without LangChain, right? You would basically just do this and let me add this. So take note, I'm still using the last LLM that I had created in the models. So it's still there. I think it was a Grok. So we'll still use a Grok, right? The last Grok LLM. So let me do display markdown so that I get the proper markdown version of it. So you see, yeah, this is nice. Okay, everything. But the issue now is, um, if I had to do this in so many places, you now have the prompts scattered all over your code base. If I want to refactor code base, I may affect prompts. If I want to change the prompts, I have to go and change code base. And for those of us who are building apps, you see how difficult it is. PRs can become so huge because you're just modifying things, right? So, um, LangChain helps with that, right? If you want to enforce a consistent structure, it's also difficult. It's easy for you to introduce formatting bugs into your prompts, and you don't have any validation of required inputs, or you may have to write your validation manually and all of that, right? It's difficult for you to uh, have versioning of your prompts, which is a very important thing. Because when you are going to an enterprise environment to build code, the prompt, remember I mentioned it already, prompt is like, it's also a program. It's also code, but it's written in natural language. It's also a program that you are giving to the LLM, right? You program LLMs with prompts. The code that you are writing, whether in JavaScript, Python, or whatever, is not for the LLM. It's for your internal system that you want to interface to the LLM. But the LLM, you program LLM with prompts. And so just like every other thing, you want to be able to know when things have changed and to confirm, especially if maybe the LLM begins to misbehave and you say, okay, what happened? Let's go check all the changes that have been made in all the prompts. So you want to do versioning and version control. So these are some of the things. And LangChain really helps with that because with LangChain, a prompt is a first-class object. And it does that by introducing this concept of a prompt template. So from LangChain core, you can import a prompt template. I'm still using the chat grok that I did, and I'm actually still going to recreate this, even though I have created it previously. I'm still going to use the Llama 8 just to demonstrate this, right? So you can now see that we create a prompt template. We now specify what the input variables are, topic and level. And then this is the actual template. Like I said, this template, even in this case, even using LangChain, is still looking a bit ugly because I'm typing all of this. If it's a really long prompt, it's not going to look nice. So later on, you will see how we can pull a prompt template by creating it from a file so that you store your prompt in a file and you do the version control in a file. But the main thing is that we have defined the variables and we have this placeholder, which is like standard, the way we use it with Python, F strings, or even JavaScript. The only thing is that if you were JavaScript, you will have a dollar here, right? But we don't have that. So this is like, it's not a mustache either. Mustache has double braces, but you just use single brace in a prompt. You use single brace and then you put the name of the placeholder they want to swap out. So with that, you create a prompt template. And then when you create prompt template, you now format the prompt by specifying how the actual values that you use to replace, these placeholders. And with that, you invoke the LLM and it's still going to give you the same thing, right? So this is what LangChain brings to us, right? In the context of prompts. It makes it really easy for you to manage prompts, to modify them, play around with them, and so on. So one of the key advantages is that from a groking standpoint, groking means looking at the code and understanding what is going on without thinking too much or giving yourself a headache. From that standpoint, it's easy for you to look at this and to know what was the inputs, that are injected into the prompt, right? The dynamic parts of the prompt. Also, the prompt is reusable because you can still take this prompt again and inject another set of parameters, and then you invoke the LLM with that. And the formatting is consistent, right? Now, in most cases, like I said, you have other ways you can handle prompt templates. So there's a specialized class called a chat prompt template that is specifically for chats, right? So with a chat prompt template, it's easy for you to create it from messages, right? And if you look at these messages, it follows the kind of pattern that we normally follow, where you specify system, prompt, system. First of all, you specify the type. So note that when we were calling it here, we were in the models thing, we were using a dictionary where we specify um, role, system, content, blah, blah. Here, you don't need to specify those keys or those names. It's already structured in such a way that it knows that the first one here is a role and the second one is a content. So you just say, okay, it's a system message and this is a system message, right? It's a human message and this is a human message. There's a third role called the AI, right? Which is a response that comes from the LLM. There's also another role called function, which we use, or tool, right? But we're going to talk about functions and tools later on and how LangChain handles those. Okay, so you can easily now have this list of messages. So you can already see we have a history here. You have a system message, you have a human message, and we can invoke with that, right? And you see, you still get, it, it understands. It basically simplifies things for you. If you're using LangChain, see how much easier it is to do that. Okay, so explain topic at level. So these are the dynamically injected, explain gradient descent at a intermediate level, right? Intermediate level. And it does that. Now, you can even go a step further, right? Because normally without LangChain, you would have had to do this, okay? And I'm not going to run this code. Well, I could if I'm using an OpenAI, I would have to create a new OpenAI here and use, let me see how fast I can do that. Since I've already imported OpenAI, I can just do client equals OpenAI and base URL equals, we use OpenRouter. Okay, thank you for that. And we get that. So, and then these are the messages. So again, see, if we're using a normal SDK, we'll use role, system, content, blah, blah, role, user content. And I'll have to do this, right? There's no way we can interpolate at runtime, the dynamic components. I have to still put it here, right? And then we can do this. And because this is this, I'll use, this is OpenRouter, I'll use NVIDIA Nemotron. Let me go get that quickly. So I was using the small model, right? Nemotron Nano. So yeah, and then even here, I still need to remember, right? Response choice is zero message content. It's still difficult to manage. So this is what I would do, without LangChain. But with LangChain, you see, there's not much of a difference, but there's a little bit of simplification. But the main thing there is that I can actually have, placeholders even in this context. And LangChain will be able to go through this list. Remember, the prompt has a whole list of messages. It's not just a single message. So it's able to detect all of these placeholders and replace all of them, right? As opposed to maybe if I didn't do that here. So it takes some work away from us and makes it easier for us to do the same thing. Okay, now, so when you look at all of this, maybe be asking yourself the question, what's all this role content? Can it even be easier for me? I don't have to be doing this role content. And LangChain has you covered even in that, right? It kind of makes it turns it into classes. So it makes it easy, right? It makes it easy. So you don't need to do the manual role handling, right? Because that's the current problem that you have with this method. You still have to do manual role handling. There's no validation. You can't do composition. Like, we're doing composition here. So you can't do composition. You can't do composition, but you can do it with LangChain, and it's harder to refactor. So LangChain allows you to do prompt composition. And the way you do that is instead of having to do all of that, you basically use the inbuilt classes that comes with prompts, system message prompt template, human message prompt template. So remember, we already had a chat prompt template as well. So you can then create this. So in this case, you don't need to type system again because you are creating a system message prompt template. So LangChain knows that this is a system prompt. And for human, again, you don't need to do that. It knows this is a human prompt, and you can also put in the placeholders. And you just do this, right? You create a chat prompt. And the same way you can actually run this, you can run this, right? In fact, one of the things which we'll come to is that with LangChain, you can actually, right? You can actually chain the whole thing. We're going to talk about that when we get to the chain part of it, right? So chat prompt dot format messages, and then we can put in the values. So we can say topic equals machine learning, and level equals beginner. So this is basically going to give. Now, an interesting thing I think I would like us to do before we invoke is let's even kind of just look at what the prompt looks like. So you can even do chat prompt. Let's see what it looks like. Of course, it's just a class that contains a bunch of stuff, but we can do format messages. And if we do format messages without specifying anything, it will tell you that some things are missing. So it actually knows from here, it actually extracts the placeholders. So, and that's part of the validation we are saying. It does validation. If you don't specify values for these placeholders, it will keep bothering you until you specify all of them. So it's now saying key error, right? So we can now say topic equals machine learning, right? This would still give us an error for the second one, level. So then level equals beginner. So we'll now look at the resulting prompt that comes from this. So you can see it's still a list of all of that, but you can see it has replaced your AI tutor who explains concepts clearly. That's the first one. Explain machine learning using an example suitable for beginner learners. See, so it does that. I can then take this and inject it into the LLM call, right? And I can invoke. So let me just put this way so it's easy to see, right? So you can now invoke the LLM with that. It's going to basically we've extracted it out and that's it. So this let's see response equals that. Then we can again because we are using a stable same interface, right? We can just mark down um response.content because LangChain has, you know, so you can see how easy it is to use LangChain. You get response. You don't need to figure is it response or message is zero or is it response dot whatever, all of that stuff, right? It simplifies it. So that's LangChain. You know, the last most powerful part of it is this, that system messages, human messages, AI messages, and all of that is now crystallized as classes that allows you to do data validation on them, right? So it's difficult to do this cleanly with raw strings. You can see how clean it is, right? One thing like I said, is you can even pull prompts from files. So this is from template, but there's also a from file function that allows you to create prompts by just referencing the file where it is stored. So that's it. It makes things very clean, right? It allows you, the prompt you use is high, input validation is explicit, like I just showed. Chat role handling is built in, so you can easily just, decide the role. So you will not even forget, okay, what the role is supposed to be or not, right? Prompts composition is native and maintainability. So that's what prompts do. They make it really easy. And LangChain forces the prompt to be structured, testable, reusable, maintainable. In the new dispensation, this is the most important thing to remember, that prompts are code. They're just code that are written in natural language. And the only way you can program an LLM or communicate with or instruct an LLM is with prompts. And it's a natural language. So later on, we'll talk about some other things you need to remember for prompts. Like you should actually write test coverage for your prompts. A lot of people don't know that. You will write test coverage because if not, you will not know when somebody has messed up your prompts. So there has to be test coverage. So let's talk about chains next. So a chain basically is one of the things that makes LangChain, right? That's why it's called LangChain. It's a long chain. A chain is structured pipeline that links multiple steps. The model, the prompts, the tools, the data sources into a single repeatable workflow. So the chain allows you to do deterministic orchestration as opposed to autonomous reasoning and orchestration. So what does deterministic orchestration mean? It means that you already know the sequence of steps that you want the LLM or agent to do. So you specify it for them. That's deterministic orchestration. But autonomous reasoning is where you do not know the specific steps because there are other variables that you want the LLM to figure out. After figuring out those variables, it needs to come up with the steps that fit those variables, which may be different. And that's agentic. So agent, the main difference between a chain and an agent is a chain, you know the steps exactly, so you sequence the steps yourself. But an agent or agentic, you don't know the steps. So you program the agent in such a way that it will figure out the steps based on observing the parameters and reasoning about them. We'll talk about agents later on. We did prompt chaining earlier on, right? So now let's look at a scenario where you are trying to build a document analysis service, right? There's a long technical document. You want your prompt chain to summarize it and extract the key action items and format the results as a structured text. This is basically a simple, straightforward chaining event or chaining task. We could have done it with prompt chaining. In fact, one of the things I'll ask you to do is the first prompt chaining exercise that we did, do it with LangChain now and see how much easier it is, right? This is not an agent problem, like I said, because there is no decision making involved, right? You don't need to think about it. There's no tool choice. There's no tooling, right? So it's just a repeatable workflow that you already know the exact steps that need to be taken. And the steps are pull in the document, ask LLM to summarize it, ask LLM to extract the key actions, and then format the results. So these are basically three prompts that you would do in a prompt chain. Prompt one is summarize this document. Prompt two is extract the key action items. Prompt three is format the result as a structured text. Okay. So you can just do, without LangChain, you would have to roll this up. Okay. And we can actually do that right now. Um, yes. So you would first of all call a summarize. So you have a prompt, summarize the following text. Okay. Then extract actions. So you would do this and analyze document would be you call the first one, which you already have a prompt that you have written, and then you call the LLM. So I assume I still have an LLM instance I can just reuse for this. So I don't need to go and create a new LLM instance. So I assume it is still there. Yeah, it's still there. The one I used for the template. So we can still reuse that. Um, so yes, we'll just use that LLM. We'll call invoke prompt content, extract it. So this analyze document is actually going to do that. And then it returns this. Okay, the return, I did not ask an LLM to do it, right? I just did it manually. So this is very easy. In fact, the first thing I'll do is let me even create a document first. So I'm just going to create a new file. I'll call it document.txt. Okay. And I'm going to go look for something. So somebody just posted on the chat that sometimes it's very difficult for a document because it's very long. You don't know where to start. So I'm going to give you a good idea. Let's copy this entire page, right? And I'm going to just dump it into my document.txt. And then I'm going to ask my summarizer to summarize it. It's a whole bunch of stuff here, lots of stuff here. Um, Lots of stuff here. So no problem. It's document.txt. Probably I should have made it as HTML. So yeah, I could do it as HTML, or I can do it as text. Let me leave it as text. Okay, so we have document.txt. Language models should be able to do that. So to do this, I will, of course, first of all, just load the files, with open document.txt, right, as file. Um, so text, okay, document, gave me that already. So that's it. And that's it. I want to print it this time instead of, um, even though it won't look nice, but whatever. So we open this document.txt and we read the file into this document variable. And then we pass that as the argument into this analyze document. Analyze document is going to call summarize. Summarize is going to generate this prompt, and then it will pass into the LLM to do that and return the content. And then after that, it will call an extract action, which is the next one. I have another prompt that does that, right? And then it will inject that summary, and then it will pass that prompt into the LLM to invoke and return the content. Simple. So LangChain made it really simple for us to do that. And yeah. Okay, so this is a small model, and I think I overloaded it by giving it a very large document. So let me see if I can make it a bit smaller. If I can make it a bit smaller. Rename. Let me rename this to document.html. Let me look for a smaller file. Let me just say small file that needs summarization. I know Google will come up with something. I'll just copy what Google did, and I'll just paste in my document.txt. Okay. And all right, this is 14 lines, so it's not as long as the other one. The other one was 1,000 or so. So let's run this again. Okay, so you can see that it now gives me this. I don't know if display or print, which one will give me a better outcome. Right. So you see how fast this happened, right? Text discusses two methods for summarizing small files using AI-powered summarization tools and manual summarization tools. So this is a summary, even though it's pretty long for a summary anyway. And then these are the actions. Here are the action items extracted from summary one. Choose an AI-powered summarization tool, um, and all of that. So this is a manual, you know, pipeline. Even though manual is still simplified because I'm using LangChain's LLM. Imagine if I had to use, well, I'll probably still have a function that I have created that does this. So that's why it's irrelevant in this case because I'll probably have created a single function to call the LLM and do that. But now let's do this with LangChain. So first of all, the problems with without LangChain is we now have prompt mixed with orchestration. So we have this is orchestration. We still have the prompt being thrown in here. We don't have a standard interface between the steps, right? I can do it anyhow I want. It's hard to add logging or retries. It's hard to do any other thing in between because basically I have to come and change this function, right? And there's no visibility into the intermediate states. So for example, I cannot see the results from the first prompt. I cannot see the result from the second prompt and so on and so forth. So it's if this thing failed and I wanted to troubleshoot it, I would have to come in here and start writing some code. Okay, print this, print that to see the things that are happening in between, right? Um, so it's difficult, and then error handling can also be very messy. So, but what LangChain does is that it allows us to do this in a declarative manner using their LLM chain class. So the LLM chain allows you to encapsulate anything into a chain, and then chains can be chained, right? So in this case now, I'm using ChatGrok, right? I will import the LLM, the chains from LangChain Classic. So this is, like I said, an old way of doing it, but we're still going to look at it. LangChain now has a new approach that uses a LangChain proprietary language, right? Which we will look at not today, but in future. We still have a prompt template, of course, and then we have ChatGrok. So you can see the three elements here, the LLM, the elements, the prompt element, and the chain elements. These three are the three we have looked at so far, right? So we create an LLM from ChatGrok. We create a template, from a prompt template, and we specify the input variables, and then we also pass in this we as a placeholder. Then we create a chain. So we create a chain by using the LLM chain class, and then we specify the LLM that's in the chain. We also specify the prompt that is in the chain, right? And there are multiple things that can be in a chain. So if you even look at the LLM chain, you will see that multiple things that can be in a chain. You can go check their documentation to see all the other things, but we'll see a few more as we go down. Then we will now open this document like we did before, right? And we will read that document and then we'll just invoke the chain. Now you may ask yourself, okay, it's not that much different from what we did here, right? The only thing is we could have used the same LLM, we could have used the same prompt, but you would see what makes this very useful, right? So just by calling chain invoke, right, we get the response. because we've created a chain with an LLM and a prompt, and we get that. We get the text, and this text, we specify that chain.invoke, we specify the input, and we specify text, right? Interestingly enough, it is able to directly figure out where to do the text replacement because we specify text as the input variable. Okay. And I could then reuse that same chain and pass in a different set of stuff. So in this case now, I have a different prompt here, which I need to find where that prompt is. I think I had this prompt already. Let's see. I will have to create it. Oh yeah, it is that prompt that we were using where we were asking about the prompt still exists. I just want to be sure. This is a summary chain, but we still had the chat chain, the chat prompt. If you go back to where we're looking at prompts, if you remember that there is actually a chat prompt here, which we had created to use for, this is it, right? Where we said explain a topic, blah, blah, blah. So this is still alive. This variable is still alive. So we are going to use it. So the interesting thing is that I reuse that prompt, okay? In this chain, I create a new chain and I reuse that same prompt with the new LLM, okay? So it's that reusability that is the most powerful thing. I create a new LLM chain. I use the same LLM I just created, and I use another previous prompt, right? And then I run it with this saying this is a topic, neural networks beginner. So you see how powerful it is. I use this chain is for summarization because it's a different prompt. But here, this chain is for, this other prompt. So you can see how it's very easy to just compose things. I take this same LLM and I use a different prompt and I run it, you know. I pass in the placeholders, right? Here, it needs a neural network and level. If I did not specify all these placeholders, we would probably have issues or challenges, right? And there are two ways you can run, right? You can use invoke where you specify input equals text. That's a new way of doing it. But you can also use run, which is the old way of doing it. That's why you can see it tells you that the method run was deprecated and you pass this. So we'll probably be moving from using run to using invoke more often. But generally, this approach of using chains is even also kind of phasing out. But you see how simple that is. Then we have sequential chain. So LangChain Classic. So a sequential chain is what allows you to basically put all your chains, in a row, like queue up your chains. And then you can run those chains one after the other, which is what a chain is actually, isn't it? So we first of all create a prompt template that contains the first one. The first prompt is from this summary, extract action items, right? So that's the first one, action prompt. So you create a chain from that using the same LLM and you give it an output key, actions. Then we now create another chain called the summary chain, right? And we use the summary prompt, which we had created earlier, okay? And the output key is summary. And then we also have an analysis chain, which is a sequential chain that combines the summary chain and the action chain. So that means you will first of all summarize and then action. And then we specify the input variables. So the input variables, you can see that the first input variable is the input variable in the summary chain, which is the text, which we already have here. And then the output variables will be the summary and the actions. So we already have these keys that we defined, and we now use those to define the output variables. Verbose is true, meaning that I want it to tell me everything it's doing. And then we just run this chain, right? We just run this chain. Then the text is what we want to summarize. So let's take this document again. So we are going to load it again with, yeah, text is this. So this is going to be the text, right? And we will run this chain. And you can now see how we have been able to chain the whole thing, right? We can print it. So we have chained the summary chain and then the action chain, right? And the result will now be a JSON that contains these two variables, which are the outputs from the two chains. Run not supported when there is not exactly one output key. Okay. So let's use invoke and then specify the input is text. So you can see that we get this, right? You have a chain is finished. It even gave us, you know, the verbose is what tells us, tell me a lot more about what's going on inside there, right? So you see that this, let me use display, right? So do you see how easy it is for you to forget that you're actually calling LLMs? You don't remember API keys anymore. You don't remember how to pass the output or where to get output from and all of that. LangChain has raised your level of thinking to the next abstraction level. So you're no more thinking, how do I pull this output out and all of that. Okay. So you can see the finished chain. It still has a text, the original text. And then this is the summary, right? Which we have summarized. And then you also see the actions, which is the third. So it gives you all the intermediate um, results from each element of the chain, each part of the chain. So you can see that LangChain automatically passes the outputs between the steps. It also gives names to the intermediate results based on what you call the output key, right? And then it handles the output wiring, input and output wiring. It enables logging, simply by saying verbose is true. Did some logging, and then it makes the workflow explicit. So if you didn't have LangChain, you would have to do a whole bunch of function calls, passing strings around, writing your manual glue logic and hidden states you have to store. But with LangChain, it's declarative. You can see things, you know, declarative coding language is always the best because you don't need to, there's declarative versus, is it imperative or executive or procedural? Where you have to really look at the code and understand the logic and all of that. But this is kind of like saying, okay, you can look at the code and see things, you know, as they are happening. You can think about things that they are happening. And you don't need to know about what's going on inside, but you can trust that what's going on inside is okay because there is validation, because there is testing. If something goes wrong, you can even do debugging. So it helps you to build more code without thinking too much, right? So, and you have name steps, you have explicit data flow and observable execution. Now you have a newer API, which I'm not going to go into this today, but we'll look at how to do that, where you can invoke a chain, specify the text using the runnable, right? The runnable. Basically, you can actually create chains by doing this, right? Using this, there is this pipe symbol. So instead of assembling your chain this way that we did by creating a sequential chain, and then you specify all the chains that should be in that sequential chain, right? The more modern approach now is define this as chains, right? Or even the elements of chains. It could be anything like this summary prompt. You're basically saying, take this prompt, chain it into um, the LLM, right? Then the output from that, chain it into the action prompt. Then the output from that, chain it into another LLM, right? So this is now the modern way of creating chains, right? I don't even know why we need this, but let me just see if this runs. Okay. So it says the content is an error message indicating that no text was provided. Oh yeah, okay. So let's see. Input is a dictionary. Let me try text, which we already have from a previous one. Okay. So you can see how easy it is. We don't even need this, right? So I just took it out. You can see this is really how LangChain now works. Okay. So let me go back and kind of make it clear. We actually did not need to create any of these LLM chains, right? All we needed to do was build the components of the chain. So we built a summary prompt. So remember what summary prompt is. Summary prompt was a prompt template. Okay, so we created a prompt template and we specify the input variables text, and the template summarize the following text. And we mention the text. Okay. Then after that, we have created the LLM, which is the um, chat grok, right? So chat grok. Let me hide this because this is like the old way of doing it. Okay, this is the old way of doing it. Um, and this is a new way of doing it. So this is the new way of doing it, the modern way. So you create a prompt template, you create the LLM, you create another prompt template, you create another LLM, and you just chain it this way. So from the prompt template, this pipe symbol is the regular pipe symbol, above your enter key, shift, right? So what this is what LangChain does now. Take this prompt, send it into the LLM. The result from the LLM, send it into the next prompt. So the next prompt will take it, and if the result is something you can inject, it will inject. And if you look at the action prompt, let's look at the action prompt again. Yeah, the action prompt was actually defined here. You see that you have input variable summary, right? From this summary, extract action item summary. And the remember the summary is what the next prompt would take the result from the LLM as the input variable, even though it is not specified, right? It's not specified, but it kind of figures it out that way. And that's what it takes as the input variable. It replaces it, and the resulting prompt from that, it feeds it back into the LLM. So with this, you can actually invoke the entire thing, and this is what you get, right? So this is something we are going to look more at this, but this is basically what LangChain looks like now. You basically chain stuff. This is a chain in LangChain. So architecturally, right? With LangChain, you have predictability, you can test, you can compose. This is the height of composition where you are taking this and you are basically composing multiple things. And then you have a clear separation of consents. So the rule of thumb is if you know the steps ahead of time, use a chain. And with LangChain and this syntax, it becomes so much easier, to just chain stuff. Let's try another example just to before I go into tools. We still have tools, memory, indexes, and agents to look at. But let's try this, okay? Or maybe I'll give this as some kind of example. Um, so another example would be we're not going to use sequential chain, like I said. There was a prompt chaining task which we did before, which I'm going to pull out, right? And maybe I'm just going to borrow from any of the submissions what was used as the prompts, right? And then we will see how we can basically summarize that. So while that is loading, okay, the one thing, like I said, we need to differentiate between when to use a chain and when to use an agent. For chains, you already know the sequence, right? It's clear and it's obvious. So that's what we call it's a fixed workflow, right? Because the parameters are clear, so you know the steps. But for a dynamic workflow where you don't know the steps depend on the situation at that point in time. So that's where you use an agent. For chains, it is deterministic because again, the steps are clear while it's non-deterministic. For chains, it's also faster. The steps are clear. You are pre-coding it, right? You know the prompts. You already, know what to do, right? So you write it out. You write the steps out. You already know the steps. But agents are slower because the agent has to go through a reasoning process, a discovery process, maybe even using your tools and functions to pull out what it should be doing, right? So um, it takes longer, right? And then last is it's easier to debug chains because most things are static. But with agents, it's more difficult because of the dynamic nature of what is there. Okay, so um, chains are like functions, agents are like programs, right? So the key takeaway is that the chain allows you to scale beyond a single prompt. You can build an entire pipeline, you know, and you can, but the other thing is with chains, you don't overuse agents. You only use agents when agents are needed, right? In most situations, you first of all check, can I use a chain for this thing? Can I use a chain? It's only if you find that there's so much dynamism and the workflow is not clear, right? And the dynamic components will have a lot of effect on the sequence or the length of the sequence or the particular things that would need to be done, then you go for an agent. But if not, you just go with a chain because a chain is simpler to implement. So this is something that everyone needs to take away. So I'm going to move on and talk about tools, right? At the end of the time, if I may take another maybe 10 minutes to finish the rest, but if the task comes up, I will try using um, this chaining method to solve the prompt chain issue or task that we had before. So let's talk about tools. We've already looked at tools. That's what we looked at on Wednesday. A tool is basically a way for you to give your LLM additional capabilities to turn it from a reasoning engine to actioning, things, even though you are still the one that will execute those actions, right? So you connect your LLM to the external world to do things that it normally would not be able to do calculations, database access, API access, files, and services, right? So a good scenario to look at is you're building an AI assistant that will answer your question, then perform calculations, and then do a query on internal services. For example, what is the total cost if we buy 17 units of so and so at this and add this VAT, right? If you are using a text, an LLM, which is basically a language model, it cannot do maths. Language models cannot do maths. This is the truth. And this is something that I think a lot of people don't understand because the chat GPT that we are working with actually have kind of been, you know, upgraded or, they've been um, pumped up or amped up with these other capabilities. But traditionally, they cannot do it, right? So um, it's very, very important to understand that. So that's why sometimes when you go and look at when you go and look at what all of these user interfaces, the UI of ChatGPT, Claude, and so on do, what you need to understand is that the language model at the back end cannot do those things. It is the code in between that has been written to empower the language model that is allowing them to do all those things, right? So that's very important to understand. So if you're given direct access to GPT-1 or 2 or 3 or 4, on which ChatGPT is based, it wouldn't be able to do as much as this. But they have been augmented with RAGs, with tools, with memory, with all of these things. So they now look like they can do all of this great stuff. So that's just what I wanted to point out. Now, if you were going to do a tool call, we've already done this, so I'm not going to dwell on this. You would basically manually write the logic, the functions, calculate units, handle user inputs, right? you know, and then you would do manual parsing to get this information out. And then when you get the information out, you would do the calculate total. Normally, the manual parsing, you would ask the, okay, if the user sends you the input, you can manually pass it out, or you can send it to the LLM to pass it and give it back to you as a JSON string or something. We did all of that before, right? We did that just a few days ago. And you see that you have to hard code passing. um, LLM cannot decide to call tools, even though if we add a tools request to it, right, we can actually tell LM, okay, here are tools, right? You can call it, right? But you can, if you could remember, there's still some difficulty around it, especially when we're doing it manually. It was better when we use the tools capability of the SDKs. The SDK allows you to put a tools thing, and then with that, it will be able to look at the tool that you have given to it and tell you, okay, I need to call this tool or I need to call that tool, right? But the other thing is that you remember, okay, even Gemini allowed us to directly, inject the function itself, and it was able to call that. That is actually not standard. That's more of agentic now, right? Because it's able to do all the sequencing by itself. But the other thing is, this approach we used last Wednesday for tool calling, the main problem is if I want to swap from one LLM to the other, I have to rewrite the code, right? Apart from the general issue. Then the logic doesn't scale, there's no generalization, and these are all the problems, right? Now, typically, if you don't give LLM, let me try this and see. If you don't give LLM tools and you ask it to do maths, it's going to mess up. So this is a good example, right? Even though here it looks like this particular LLM has some tooling at the back end, so it might be able to solve this. But what is 17 times 12, 12450 plus 7.5% VAT, right? Well, I think it figured it out because it basically used agentic steps. So the first step was to multiply 17 by 12,450. I'm going to validate that with my calculator, or maybe we can even validate it with some code. So 17 times 12,450, and so that's correct to, well, that's not correct actually. 211650, 211350. Well, maybe it's already done. So you can already see that it has made an error already. 17 times 12,450, it says it's 211350, right? But our own calculation here using Python, 17 times 12,450 is 211650. Now, there are these things we sometimes used to do, like you could tell ChatGPT to do a mathematical calculation and you give it the wrong answer. Then when you tell it, okay, write a Python program to solve this math, the same math, it will give you the right answer. Because when you gave it the answer, it didn't reason enough to know it needed to use a tool, right? But when you told it write Python code, an LLM cannot write Python code on its own. So it uses a tool to generate the code. Even though it would generate the code, well, it can generate the code itself, and then but it needs to run it somewhere. So that's why it uses a tool to run the code, and the answer comes back to it, and it will tell you, oh, okay, I actually got it wrong the first time, right? So now that's that. So you want to do 7.5% of VAT. The simple way I would do that is 100% plus 7.5%, which is 1.075 times the 211,650. Okay, and it didn't get the answer. So you can see it didn't get the answer. It came close, but it didn't get the answer. right? Because 7.5%, I could even say it's saying 7.5% of 211,350, right? Let's try that, which is 0.075 times 211,350. That is, I'm using its own values, right? And I'm getting 1585.1.25, but it's telling me it's 158 26, right? 0.075. So this exact same thing it's saying it's doing 0.075 times 211,350, right? It's telling me it's 15826.25. But when I calculate it with Python, Python gives me 15851.25. So you can see that LLMs, they are language models, they're not mathematical models. They don't know how to do maths. So it's already hallucinating a lot of craziness here, right? So LLMs are bad at precise math. Results may look correct, but be wrong. We've just seen it now. If I wasn't double checking, would have I would have thought, oh man, this thing it's almost close. One digit is missing, 201,350 versus 201,650, right? And here 15851.25 versus 15826.25. One digit is missing, right? So it is not a good idea to let the LLM do the maths itself. It is better that you tell the LLM to use a tool to do the math, or let it reason about it and choose to use a tool. So let the LLM decide when to use them. So in LangChain, right, we are going to go straight to LangChain. It's very easy to define a tool. You import this tool class, right? And when you import this tool class, any function that is a tool, like we saw before, you use this tool annotation. And this thing will apply both for JavaScript, right? TypeScript and for Python. So you specify, okay, this is a tool. So when you now create, there are two ways, by the way, that you use LangChain. The first way is when you define an LLM, then you bind the tools to the LLM. So you tell the LLM, hey, guy, these are the tools you have, right? And we have defined them as tools already. Okay. Um, Let me take this out. I'm not doing agents yet, so let me take agents out. Um, and this is chat croc. Well, I don't need to do this. Anyway, let me still leave this here because just for documentation purposes. Okay, so let's see. LangChain grok. LangChain grok. Okay, so we've created an LLM with tools, right? An LLM that knows a few tools. Then what we can now do is we now call this LLM with tools and then we give it a prompt. What's the weather like in Boston? And the interesting thing is that that LLM will have two calls. That response will have two calls. We can actually display the response dot two calls. So like what we did last time, we'll see that if the LLM wants a two call, it will populate these two calls with something, right? Of course, LangChain is pulling it from the response from the API SDK or whatever and putting in two calls. And then you can then check the two calls and you can see the two calls. There are different two calls, the name and the argument, right? So because we have defined this already, you can see that we have a single two call here, right? We have a single two call. The name is get weather, and then the argument, actually I should use print. I think print normally formats um, things better. So you see name is get weather, the arguments, location is Boston. We had already defined it here with location. So location is Boston and a bunch of other things because LangChain is able to basically generate the metadata that is needed for the tool call here. So this is basically saying the same thing. So just like like before, we can now run this LLM, but we need to add information about the tool call, right? We need to add information. Here, I didn't do that, right? If I do this here, oh, that's the wrong one. Yeah, that's the wrong one. Invoke. So, but when we were doing this tooling thing, right? There is a way we were able to call the there's a way we were able to call the uh the LLM afterwards and give it the history, right? Now we can do the same thing with LangChain, but there's a better approach which we'll talk about later. So, um, yeah, there's something I think this was just weather thing. I should have done the maths thing though, but that's okay. That's okay. Um, okay, that's okay. So let's go with the weather. So with this, we will have to um invoke the LLM with the additional information. So let me do that now. So remember, we will have to do this like a stack of prompts. Okay. Um, so if you recall, we first of all did we'll have to have a stack of prompts. So the first one will be we can create a system prompt and all of that. So but it's better to stack with human message prompt template, right? And then we'll just uh, um, from template. Yeah. Um, so we'll get the human, which was the original one, right? So we'll get the original prompt. I'm just going to do this. I know this is too long to fit on one line, but I'll just do that. Then AI message. No, I'm not going to do AI message prompt template. Um, we're supposed to put the um put in the additional tool call, right? So okay, so we are supposed to put in the message from the um to the AI message, right? Typically, you would just specify the AI message and the tool call. So what I'm going to do is um, AI AI message. So the AI message is is not the. I want to put in the AI message, right? And put in the because the thing is you have to follow the sequence, right? So this response is the AI message. I think we can just dump the response in here, right? Um, the response that it gave me, because we have to follow the sequence. So we start off with the request. We probably don't even need to do this. We just put in the original, what's the weather like in Boston, which is what I asked. And then I put its response in directly, right? Because its response is an AI message. That's one thing that we need to understand. And the AI message contains the requests that the LLM made for the tool call. Then we will now create a tool call response, which is, or a tool message, which is basically like, this is the result from the tool call. So that's what the LLM will now use to complete the process. So to do that, there's something we call a tool message, right? And tool message will have to import it. So let me just put that here. Tool from LangChain core dot message import tool message. Okay. So I create a tool message, and this tool message, I will now specify the result from the tool call. So the content is the result from the tool call, which we can directly do. Let's say I could, if you remember what we did before, invoke tool call. Yeah, tool call, this is what I wanted to do. So you have a tool call, tool name is tool call name, right? And tool args is tool call args. Then this is just doing it manually. And there are a bunch of ways, right, to there are a bunch of ways to call response to do this. There are a bunch of ways to do this, right? But I'll just do it this way to just for ease of understanding. So you invoke the tool call, you've passed the tool call. The tool call contains the name of the tool you want to call, as well as the arguments, like we said. So in this case, if the tool name is get weather, right, which is all we have here, you can just call get weather.run and pass the group tool args. This is one way of doing it. The other way would be just to get weather like a function call and spread out the arguments, right? So at the end of the day, the response should be the response, the content should be the result, which is a tool call response. And then the you should pass a tool call ID as well, which will be the tool call get weather dot ID. Okay. So this is one way. Tool calls are there are a lot of different ways to do it in with LangChain. So let's see. Oh, let's get it from the tool call ID response dot tool calls 0 dot ID. Yep. So response. Oh, this is a dictionary, so it should actually be a dictionary. Okay. All right. So so we're still getting tool call again, which is okay. Um, let's just directly type in the response. Okay, the tool call response. This is a prompt, so is this, right? That's another way of doing it. So let's just go with simplicity. Um, It's it's now telling me it needs to see the actual weather details, not just the conditions, which is interesting. Um, let's see. Let me even see what I gave to it. That's because, well, it's sunny in Boston, you know. Ah, well. So it's trying to be very smart, and I think it's being too smart. So I'll leave it at that, right? Now, another way to, um, because I'm running out of time. So another way to do this is to use an agent, right? Um, in fact, that's the best way for you to do two calls, because when you do an agent, the agent will handle the multi-step, which is going to basically um, do the two call. It's going to run the two call, and then it's going to take the result of two call and give it back to the LLM. So that's the best way, right? And that's what I just want to show here. So in this case, now we import the two. This is a different problem, right? I'll go back to that weather thing. So we calculate, this is a tool which is just to do calculations, right? Then we will now create an agent. So we'll have to create an agent that will do that. Okay. So LangChain agent. Okay, so we need to fix this. Um, we have what we call agent executor and create two calling agents. So um, and then we have prompts and we have tools. So um, right now for a um, you have to create the agent, right? So you create a tool calling agent, specify the LLM, you specify the tools, and then you specify the prompt. So this is an old method. So again, I have this same problem which I had before where um, the old methods have been deprecated. So the new method is to use to create tool calling agent. There has to be a prompt, right? So so the prompt is the prompt we had before, which was what was the prompt? Calculate. I think it was, yeah. Let's use the prompt. So there you could have a system prompt where you inject, or you can have this prompt directly. So let me just do this. Now, the problem I'm foreseeing here is that when I run this code, so after creating the agent, then you do an agent executor to execute the agent. tools. Um, calculate total and okay. Result equals agent executor. Okay. Okay, so yeah. Sometimes it's best to just go to um documentation and check because things are changing so fast that um we don't have agent executor anymore in LangChain.agents. We don't have create tool calling agent anymore. We just have create agent. So I just double check that. So to create an agent, you just do create agent, and then you can specify the LLM, specify the tools, and then you can just run the agent. There's a whole lot we can do with this. So I'm just kind of trying to run through this really quick so that yeah, so it has really just been simplified to just this, right? Um yeah. So we will specify, let's see if we specify, because really I should be creating it from the LLM, but um, it seems I have to specify the model rather than the LLM. So let me see if it can pull this, right? And okay, so I have to specify the model provider as well, which is what I was thinking. Provider equals Grok. So we will use Grok, specify the tools, and then we run. Um, hmm, maybe I did not spell it properly. Let me confirm. So it says unable to infer. Please specify model provider. Okay. So probably should be provider. Okay. So that's how you specify the provider. Okay. All right. So now the actual question, which is what we are trying to run. So run the agent. Um, so to run the agent, we just invoke agent.invoke. So for LangChain, when you're creating an agent, you have to specify the provider this way, and then specify the name of the model. That's the convention. And then after that, you run invoke. Okay, yes, we have to pass this in. The last time I did that, it worked, but that was with models. So with agents, it's probably different. Okay, I'll have to come back to that in a short while. So, with the agent approach, right? Typically, what's happening is that you define the tool call, right? You specify the tools when you are creating the agent, and then you invoke the agent. Um, Obviously, I'm not doing this correctly. Then it kind of cycles, and when the tool call is needed, the tool is actually going to be executed. And then when the tool is executed, the result is sent back to the agent. That's why we are using an agent in agent mode. And then it gives us the response that we want. So that's typically how that works. And we're going to look at that more when we're talking about agents. There are three other things which I would want to go in, but I'm not going to um, jump into those today. I'll leave those to when we come back. So we can look at indexes. Indexes are basically the same thing that we were doing when we were doing RAG, right? So well, this is manual RAG implementation that we did before, which we've already done. But with LangChain, LangChain allows you to load documents. So remember when we were doing document loading and you know um reading documents from PDF, reading documents from docx, reading documents from text files and other things. And I even had a resource that I shared with you to show that there is even a way you can use LLMs to read documents in a structured way. So LangChain also helps with that. Then the other thing that LangChain does to help when you are doing RAGs is text splitting. So text splitting, we talked about semantic chunking and all of that. So LangChain has a whole bunch of different classes that would do different kinds of chunking, whether it's paragraph chunking, semantic chunking, and all of that. Then we have embeddings. So we did embeddings as well. So LangChain has some embedding classes as well, which you can easily use to do embeddings. And then vector store. So LangChain allows you to use any type of vector store. It gives you the same API interface, right? For you to do vector stores, whether it's FAISS, whether it's a Pinecone, um, Chroma, and so on. So then it also, with the retrieval part as well, LangChain gives you retrieval, it gives you reindexing. Then you can chain everything, right? So like here, we did chains. You can basically chain up all of that into a RAG. So the whole um, text reading, loading the documents, chunking the documents, creating the embedding, creating the vector index, you know, and retrieving the context. You can all do all of that, with chain. So we are going to look at how to do that when we come back, but I'm just giving a preview. And then the last one is agents, which we will also look at how to use agents. Basically, LangChain allows you to write agents. It has a built-in agent. We talked about tooling just now, where you define the tools, you create agents, and then when you create agents, then you can give the agents prompts. And then we're going with that, the agents would basically use the tools, the prompts to reason about the task that you have given to them and then figure out the steps to take, figure out the tools to use, figure out the data that it needs to get, and it basically solves the problem. So we'll look at those remaining three aspects when we resume next week. So I'll pause at this point. Are there any questions? Any questions? Okay, if there's no question, I am going to. Okay, so if there are no questions, um, I'll stop the recording now. So when we come back next week,